this point. All right, thank you. Good. So I would like to first thank to the IUC board as well as ICUC board here to give the opportunity here to come and present the work itself. I would like to also acknowledge the co-authors, my student, and also other colleagues there. So it's actually I would like to locate. This is about the it's a West Texas somewhere here, and it's a small size cities, and that's basically what we're talking about. So if we sit down on Wikipedia just a random day and then you see what is the United States population in the bigger cities, mega cities. So I was surprised. There's only 9 cities in the United States that has more than 1 million population. So where do the other people live? Basically, they live in all small size cities. And in this room, I think most of us coming from small town. And this the message that I'd like to carry that smaller size town matters for urban heat island intensity. And European heat wave, there's a big picture. And if you go for like any UHI papers, like, just like take 10,000 samples, you'll see Moscow, London, Brisbane, Sydney, Paris, myself, I was working. So all the mega cities has been explored. But think about your small town has not been explored. But that also has the contribution of the small size cities matter. That pretty much it is. And major contribution of this work would like to focus on is the urban heat advection. So that brings to the major concept that we would like to explore at this point. And biggest motivation, like I said, tied for the hottest July on the record in the globe because this 2023 was the warmest all over the record in the history of the climate. So we all know this picture from the different studies, the urban heat plume, that is the famous plume we call about. And that brings to the important question here that if you sit down here the urban location and then measure the rural areas, and it's pretty subtraction, urban minus rural urban heat island intensity, right? So that, and even if you put down the sensors on the rural side, you can basically subtract that. The problem is the plume. And as you can see, if the plume is coming from southwest, and this heat plume will go and back over the northeast side. And if your rural side is over sitting over northeast, you'll be getting lesser amount of UHI. So that's the problem. And it's only 2 papers has been contributed to the Chicago study, another one in Birmingham that actually trying to contribute to the UHA, urban heat advection. So that's the major thesis hypothesis here that urban heat advection actually need to design. We would like to say that at this point that mean wind direction it needs to be a very big component of choosing where the rural site would be to make the contribution of UHII. My paper in Paris, we had only too few sites and rural sites, and that is which way the wind direction was going through. We did not have any care. But at this point, as we progressed for like last 60 years of research on urban climate, I think we need to point out the urban heat advection. So next one is that equifinality issue in the model. So when you go for like model data comparison, we go to the bulk statistics now. For some days you have warm bias, some days you have cold bias, and then come up with the knowledge that you get a zero bias. So you get the right results for wrong reasons. So that is exactly what we are actually advocating for. One more important component here that we will do model data comparison, model data mismatch, but weather specific. Weather will guide which type of days we should be comparing with model. So basically weather or region specific model evaluation, we call it, that has been pretty much experimented here at this point. We have been doing the high resolution rapid replay, that is basically the National Weather Service cares for, and this research is planning to be in the operational model. It's a research to operational component of the funded project, and we'll have to provide the input so that model can be one day itself self-calibrated and tell us which way the plume is going, and then which part of the city is or rural side will be affected more than the other part. So we did some preliminary results at the beginning before the project started to hypothesize that. So you see, these are temperature rows. So as you know, wind rows, basically wind speed is actually replicated. This is temperature, just change the color to the temperature. Then you see how does the temperature distribution changes in a over given site depending on the wind direction. So that's the $1 million question, that how we'd like to define where our sensor will be sitting for rural measurements or urban measurements. So that's the starting point. We say that there is no dominant wind for a particular site. Wind is varying every day, one over the other, and so on. So that basically the wind direction regime specific calculation we need to cover. So this is the network, we call it U-HIT, urban heat experiment around Lubbock, Texas. Lubbock is small size cities compared to any other million, 14 million, Paris, 20 million or 60 million. We have 200,000, 300,000 people. And that is the size of the city is basically 30 by 30 kilometer, pretty much. And there's a 10 by 10 kilometer city center itself. And we also make measurements around all about the urban, suburban, and rural sites around. And this is our arid region, so you have to be careful about that. You want to find out the grass, it's rare. All the grasses we actually do in our backyard, we have to pay for the grasses so that you know what arid region looks like. So four major components. We have to make the test bed operational. We make the U-HIT mobile because we also create two mobile platforms moving around the city, and we'll see some results in that. And these are the cheap sensor itself, $200 itself. Well, what is cheap itself? You can define that, right? But it's much more cheaper than the other gold standard measurements. So this is the network. It's established now. You can see everybody's. It was big crowd, and the people were so much advocating for climate change in that region, and we have been successful to deploy the instrument in the last summer. So this is basically the component. You can see all this is basically autonomous instruments hobo sensor. If you have heard about that, it's basically just don't have to enter the site. You just take our cell phone and basically can Bluetooth. You can find the data itself. And the smaller size in low maintenance and cheap sensors, and also the now with the chip thing that goes to the problem whether how good they are, right? So then we have to do the calibration with the gold standard, that is West Texas Mesonet or any other Mesonet in the United States, that is called gold standard data with respect to the measurements. So this is a West Texas Mesonet tower, and we have deployed all these 25 sensors in on this tower, and one of them at the same location, and that's the correlation itself coming to each other, or the 5 days of measurement itself, and that is pretty much reliable. Now we don't reach one number, we also see the correlation coefficient. I never seen in my life 0.999 correlation coefficient any experiment I have done. So it's pretty reliable that way, right? All right, and also the slope was pretty strong. So there we go, and that measurements were taking place at the urban, suburban, rural sites, all those sites you have seen. And now you see this is one of the day between 12 and 4 a.m. different 4 sites here, just like 4 hours measurements here, because that is the main UHI dominated site. And now it's 2 nights are quite different. You see in the rural sites you have like heat here, and the urban side heat here almost similar. And that's the thing, that urban heat advection is taking place. How do you want to quantify that? Using more analysis that we are doing. So this is the mobile experiment as well as the stationary equipment that is actually installed at those sites. So we are doing simultaneous mobile and the stationary measurements and making the measurements itself. So now you see, these are the road sites. You can see now that depending on the wind direction itself, it will be changing the temperature regime of our different rural location itself. So these are the 3 nice examples. Now you see how heterogeneous the urban heat island itself, depending on the wind direction itself. Now you can clearly see on this different platform, different days, wind directions are different, and that was the heterogeneous. So it took like 4 hours of sleep. We did not sleep like, let's say, almost 4 weeks, no sleeping at all in the whole night. We were driving around. It's a 40 kilometer per hour speed because inside the city. So we are not sleeping and making measurements all around that. So that was pretty congested measurements as we speak. Then we also moved to the other city because one city doesn't tell you the truth. We have to go to the other smaller size cities in West Texas. We also targeted some other cities, Abilene, Amarillo. You don't know the names. Basically, these are similar populated city, like 100 to 200,000 people there. And we see that kind of same trend to the urban heat advection is taking place itself. Then what the whole data looks like. Please play the animation here. So that was sitting over the, interpolated field. And I myself is not a strong believer of interpolation, but it gives us some special variability itself. How does the data look like in a special domain? So there are a lot of work need to be done whether this interpolation is correct or not. But in general, you can see how the heat regime is varying over the course of 4 hours measurements in the night. So we have a arid region that is a challenge. You have a nighttime warming is happening until 2 a.m. So we are sitting here looking at the data. When the slowing down of the temperature will happen, then we'll get out. That's pretty much the whole measurement itself. And education outreach is a major component of this field work, as well as how the students, high school and also undergraduates who are learning. We are actually making class materials using these things, and students are getting involved. And we made the community involved in such a way they are actually collecting data and they are sending data now from their stations. We don't have to go and visit those sites because people are so interested. We think the human or population or the community is the input. They are so much interested and actually contribute to the science without being paid. And these are summary and also don't come to the conclusion itself. So we actually showed that in smaller size cities matter, urban heat advection matter, and also I did not show the model data mismatches because of the 12-minute span of the talk here. But we are also seeing a very clear trend on the model data difference depends on the weather system itself. That pretty much makes that weather specific model evaluation needs to be performed, and based on research find the model around 640 square kilometer, we see up to 202 degrees centigrade temperature increase in downwind. So that's the million thing that we need to consider, not only the wind speed but also the wind direction. And without further ado, I would like to thank to the funding agencies as well as you guys. Like I said, you are sitting here and attending this talk after this tiring day. And we also want to make an advertisement here. We are also hiring PhD scholar and also postdocs. Please contact me. Thank you.
Very nice presentation, Sandip. Thank you. I think it's good to see the three-dimensional aspect of the flow really matters. Do we have a question for this presentation? So I would like to know, you compare different cities of similar sizes. What do you think would affect the differences? Is it the surface roughness or the compactness?
The urbanization is so complex. Where you're sampling, the urbanization and the with respect to mean flow is basically each city is so different. How does the urban population, urban surface is varying, the spatial heterogeneity is actually making the dominant factor. Remember, we are trying to investigate urban heat advection. So where does the heat actually from the different corridor goes to the other rural side? Because we live in the city, let's say, we can afford air conditioning and everything, but people in the rural side, they may not be able to, correct? And that heat goes to the rural side. That is dangerous point. That is exactly why it is so concerning that heat advection actually impacting the urban heat and the definition itself that we have been learning for last 60 years. Because we could be, including me, not we means including me, we could be landing a wrong UHII if we did not consider the wind direction itself, because you actually made the warmer rural side if your rural side is there. So wind direction measurements is very crucial there.
And do you think that on the flip side is also true that, I mean, we have the cooler air coming into the city?
That's a very good point. That this is actually the cooler air itself with respect to when you call in the United States the synoptic convection advection itself, cold air, cold front coming. That will also impact the other way around. We did not explore the winter data yet, but we are learning. We're just talking about summer data. But it's a good point though.
Thank you. Yeah. So how much displacement do you think there is between the urban heat island and the urban fraction? Can you maybe quantify that?
Excellent question. So now you think the wind speed needs to be there, and zero wind speed will not do anything, right? So 20 meter per hour wind speed is good and it's very high speed. And I started driving in the night, and I don't see any UHI because wind speed is so strong. And wind is not moving is also dangerous for this kind of study. You have to hit that triple point where that advection starts. And how far the advection goes is under experiment. I don't have the number. If I tell you the number, I will tell you the wrong number. Because we are actually investigating that, so far we are seeing like 7 to 8 kilometer dimension change with respect to from the city center itself.
So you gave me the wrong number. You said 7 to 8.
No, I said I could be. That's why I said I don't have the right number, because we are still studying, because these are very hot data. Even last 2 weeks ago I was driving. Like I said.
All right, thank you very much for this interesting aspect of it.